Using the dataset that we have created in Activity 1, we will test their normality using the Kolmogorov testing. We need to test each variable for normal distribution. The first condition for normality testing: significance level should be set to 0.05 or 5% of margin of error. This is our basis to whether we conclude that our data is normally distributed or not. If the computed probability value is greater than 0.05, the data is normally distributed. However, if the computed p-value is less than 0.05, then the data is not normally distributed. Now, let's try to test the dataset on frequency of absences if they are normally distributed. Let's copy them and paste on the text box. And press calculate to calculate the distribution of the data based on the probability value using the Kolmogorov or KS test. So, the probability value of the dataset based on KS test is 0.06788. Our reference that has been set is equivalent to 0.05. The probability value that we got is greater than 0.05, which means that the data is normally distributed. So, our dataset for the frequency of absences is normally distributed. What about the PD score? Is it normally distributed? Let's try to test it. Let's copy them and paste it in the text box. The probability value for the PD score using the KS test is equivalent to 0.01908. This value is less than 0.05, which means that the periodic test score is not normally distributed. Since one of our dataset is not normally distributed, then we cannot utilize the person R. In this case, we will use the Spearman rank correlation. Let us copy and paste the frequency of absences as the x values and the periodic test score as y values. Let's try to calculate. So our value for our Spearman rank is negative 0.93677, meaning that the correlation is inverse or reciprocal, which means as one value increases, the other one decreases. The correlation that had been stated is two-tailed. When the number of absences becomes higher, the periodic test score becomes lower. That's the negative sign correlation means. Now, the probability value based on the two-tailed is equivalent to zero point 0.0. The probability value is always compared to the significance level. If we look at our condition earlier, our probability value, which is zero point 0.0, is less than 0.05, meaning there is a correlation between our two variables. With respect to the strength of relationship of magnitude of correlation, 0.93 is greater than 0.40, which suggests strong correlation. Our data analysis will be the data has been tested using the Kolmogorov-Smirnov or KS test to determine if the dataset is normally distributed or not. The probability value of the first variable, which is the frequency of absences, based on KS test is 0.06788, which is greater than the significance level at 0.05. It has been determined that the frequency of absences is normally distributed. However, the computed probability value of the second variable, which is the PD score, is equivalent to 0.01988, which is less than the significance level at 0.05. Thus, it has been tested to be not normally distributed. In this case, the datasets will be utilized using the Spearman rank correlation. The statistical test or computed value for the Spearman rank is negative 0.93677, which suggests that the correlation is inverse or reciprocal. Further analysis shows that the probability value based on the two-tailed correlation is equal to 0, which is lower than the significance level at 0.05. Therefore, there is a correlation between the two variables. The computed Spearman trunk suggests a strong association or correlation between the frequency of absences and periodic test score of a student.